Hello, this is Dr. Ayoshola Ogundele, Astronautics for Exploit. Asteroid mining, a prospective contributor to the global economy. The focus points of my presentation are as follows: Asteroids, Asteroid Chronicle, Asteroid Mining Drive, and classes of asteroid mining missions. Asteroid mining, the hypothetical exploitation and extraction of minerals and other raw materials from asteroids and other minor planets, including near-Earth objects in outer space, which was once a science fiction, is gradually becoming a reality due to the realization by the researchers and asteroid mining companies that asteroid minerals are crucial for the survival of colonies on Mars or the Moon. Over several decades, the idea of asteroid mining, including how to prospect asteroids, how to harvest asteroid resources, and how to use the harvested resources, witnessed gradual evolution. Prior to 1970, asteroid mining was presented as a science fiction in the fiction works of Worlds of Eve, Scavengers in Space, and Miners in the Sky. During 1970s period, academic consideration was aimed at mining asteroids located closer to Earth than the main asteroid belt. During 1980s period, the interest in asteroid mining was shifted to the moons of Mars, Phobos, and Deimos. During this period, ideas of how to process materials in space and what to do with the materials that are hypothetically gathered from space were being generated. During 1990s period, there were various research works what materials in asteroids could be valuable for extraction. These materials include free metals, volatiles, and bauxite. Some of the asteroids' raw materials that are of interest to the asteroid miners are silver, gold, platinum, rhodium, nickel, aluminium, manganese, iron, and cobalt, and a host of others. These minerals could be brought to the Earth for use on or in space for construction purposes and as rocket propellant to the Moon, Mars, and beyond. Although asteroid mining activities are limited by the challenges of spaceflight high cost, proper identification of minerals and suitable asteroids, and the extraction of asteroid materials of high economic values, efforts are being made by the asteroid mining companies to invest in the design and development of technologies which will one day make the exploration effective. Various asteroid mining techniques are being developed and potential mining sites are being researched. Asteroids. Asteroids are solid, rocky, and irregular bodies that are the rocky remnants of the protoplanetary disk of dust and gas which was formed around the Sun over 4.5 billion years ago. During the chaotic fiery days of the early solar system, debris was constantly crashing together, and then small grains became small rocks, which crashed into other rocks to form bigger ones. Attic's concept of asteroid mining is shown in this picture. Asteroid mining possibility. The concept of asteroid mining, which was once a science fiction, is gradually becoming a possibility. The creation of asteroid mining firms and the passage of legislation that recognizes the right of companies to prospect, claim, and extract space-based resources are some of the actions that are making asteroid mining to become a reality. The picture here shows artist's impression of an asteroid mining mission to a nearby asteroid. Asteroid prospecting. With multiple companies now emerging for the purpose of asteroid prospecting, exploration, and mining, the asteroid mining idea is moving from the realm of science fiction into the world of science fact. Asteroid mining is the hypothetical exploitation of materials from asteroids and other minor planets, which includes near-Earth objects. Asteroid mining challenges include high cost of spaceflight, unreliable identification of asteroids which are suitable for mining, and the challenges of extracting usable material in a space environment. This picture shows a robotic mission retrieving a boulder from an asteroid. Presently, asteroid mining ambitions are shifting to more distant long-term goals, and some asteroid mining companies have pivoted to more general-purpose propulsion technology. This picture shows artist's impression of a robotic spacecraft orbiting the asteroid site. Asteroid Chronicle. There are a series of events that have taken place over time up to this present moment. Over several decades, the idea of asteroid mining is evolving gradually. Researchers and interested companies are working on how to prospect asteroids, mine, and process them. Over the years, various asteroid missions have been sent to the asteroids, and various missions are also being planned. This picture shows artist's impression of NASA's Lucy mission exploring Jupiter's Trojan. Historical account of asteroid mining events are as follows. Before the year 1970, asteroid mining existed within the realm of science fiction, as in Wars of Eve, Scavengers in space, and miners in the sky. During this period, researchers thought of profits that could be gained from mining asteroids. This picture shows Deep Space Industries' fuel processor concept for asteroid mining. During the 1970s period, academic consideration was aimed at mining asteroids located closer to Earth than the main asteroid belt. This picture shows an artist's depiction of a lunar base, which is sometimes called a moon village. A moon village will provide a great initial market for lunar miners. During the 1980s period, the interest in asteroid mining was shifted to the moons of Mars, Phobos, and Deimos. During this period, ideas of how to process materials in space and what to do with the materials that are hypothetically gathered from space were being generated. This picture shows illustration of scientists and businesses' exploration idea. During the 1990 period, NASA worked on the establishment of what materials in asteroids could be valuable for extraction. These materials include free metals, volatiles, and bauxite. This picture shows demonstration of underground lunar base design. Asteroid mining drive. There has been a great drive for mining asteroids. There is increased drive by the researchers and companies to set up a mining extraction and operation on an asteroid. Although building an asteroid mine will cost billions of dollars, but it will be far cheaper than carrying supplies from Earth to the Moon or Mars. This picture shows mosaic image of asteroid Bennu, which is composed of 12 polycam images collected on December 2, 2019 by the Osiris spacecraft from a range of 15 miles. Asteroid mining machinery It is assumed that asteroid mining machinery will likely be solar powered so as to reduce the need for fuel that will have to be hauled to the asteroid by spacecraft. The mining equipment is expected to be lightweight for easy transportation through the asteroid. This picture shows Pioneer 10, which was forced through the asteroid belt and first to Jupiter. Robotic equipment are being developed for asteroid mining to limit the personnel needed to carry out the mining project. Using robotic equipment to mine asteroid will reduce the amount of supplies, for example, food, which is required for a manned mission. Artist's concept of an asteroid redirect mission is shown in this picture. Asteroid mining techniques. Some mining techniques being used on Earth are being planned for the mining of asteroids. One of the proposed methods for mining asteroids is to scrape desired material off the asteroid and tunnel them into veins of specific substances. Scraping or strip mining will pull out valuable ore that will float off the asteroid. This picture shows an artist's depiction of a mission at work exploring pits in the surface of the moon. Asteroid mining steps. There are various steps that are being planned for so as to be followed for mining asteroids. Various classes of asteroid mining missions are asteroid prospecting, asteroid harvesting, asteroid processing, and asteroid transportation. Asteroid prospecting. Asteroid prospecting deals with the identification of asteroids that contain ice, such as water, hydrogen and oxygen, and metals. This can be done using a constellation of CubeSats. The business case for asteroid mining is asteroid prospecting, and the value is the proprietary information of which asteroids to focus on, and then to establish a commercial claim to explore and extract. This picture shows asteroid Bennu and other surrounding asteroids. The need for asteroid prospecting. Before asteroid mining can begin, there is the need for asteroid prospecting. Asteroids need to be firstly identified, catalogued, and assessed for the value of the minerals and resources. Robotic asteroid prospector was designed to assess feasibility of asteroid mining. This picture shows artist's impression of Japan's Hayabusa spacecraft approaching the Itokawa asteroid in 2010. Telescopic observation is being planned for asteroid prospecting, and it will initially identify asteroids as near-Earth objects, Earth-threatening near-Earth objects, mean-belt asteroids, and other orbital groupings. Robotic missions to near-Earth objects. Initial robotic missions to near-Earth object asteroids of commercial interest will confirm the size and composition of different types of asteroids as being rocky, metallic, or carbonaceous, and identify the actual abundances of minerals on each one. This picture shows illustration of Trans-Astronautical Corporation asteroid mining concept. Asteroid mining probes. Asteroid mining probes are designed to estimate the structure of the asteroids as being apparent rubble piles of loose fragments or made of solid, non-fractured rock and metal. Asteroid prospecting helps governments to plan planetary defense against threatening near-Earth objects and assists mining companies to decide which asteroids to pay attention on. This picture shows illustration of a spacecraft landing on asteroid. Deep Space Industries designed unmanned Firefly spacecraft to prospect mine-able asteroids that fly near Earth. Dragonfly spacecraft for the purpose of bringing back samples from likely candidates. This picture shows artist's concept of Firefly spacecraft of deep space industries for asteroid mining. Asteroid harvesting or mining. In order to be able to mine the asteroids, several things must be put in place. For example, infrastructure must be built in low Earth orbit and beyond to support asteroid mining operations. A fleet of mining robots and haulers capable of extracting ore and resources from near-Earth objects and hauling them back to Earth are needed to be built. This picture shows illustration of asteroid mining. A series of orbital platforms where vessels can dock, offload ores and other resources, and refuel are very important. Once mining operations extend beyond near-Earth objects, these platforms will need to be built further out as well. Asteroid mining orbital platforms are needed to be set up in orbit around the Moon, Mars, and the asteroid belt, or wherever mining operations are taking place. The depiction of ESA's mission to the Didymos binary asteroid system is shown in this picture. The construction and maintenance of asteroid mining infrastructure involves a process known as in situ resource utilization, which refers to the use of locally harvested materials for manufacturing necessities like a propellant, components for orbiting platforms, oxygen, and even construction of spacecraft. In situ resource utilization will help to simplify mining operations and reduce cost. Artist's concept of DSI Dragonfly is shown in this picture. Minerals could be removed by a spacecraft using scoops, nets, and augers. Shaft mining is another possibility, where spacecraft equipped with drills bore into asteroids to extract the materials within. A prototype of the asteroid redirect mission robotic capture module is tested with a mock asteroid boulder in its clutches as shown in this picture. Asteroid mining techniques. Another asteroid mining technique is net capturing. Asteroids can be captured using nets and then towed closer to the Earth. Once in lunar or low Earth orbit, they could be mined by smaller extractor spacecraft, which would then transport the resources to orbiting platforms. This picture shows illustration of Trans-Astronautical Corporation's Mini-B spacecraft chasing down and capturing an artificial asteroid in low Earth orbit. Another asteroid mining technique is through the use of steam propulsion. Steam propulsion is another method that has been proposed. In this case, robotic spacecraft will harvest the oxygen in water ice to manufacture propellant, giving them a degree of self-sufficiency and the theoretical ability to mine indefinitely. This picture shows illustration of asteroid mining. Asteroid processing is another class of asteroid mining missions. Current asteroid processing proposals suggest placing processing facilities in Earth or lunar orbit with regular access service to the asteroid beds. The remoteness of these facilities will make them difficult to create and maintain, requiring significant advances in robotic technology. This picture shows demonstration of asteroid mining. Asteroid processing. The extracted asteroid can be sent to either Earth or a space colony. The rocket fuel for a Venus spacecraft could be produced by breaking down water from the asteroid into hydrogen and oxygen. This picture shows an artist's concept of a sediment taking shape as part of an asteroid mining operation. Asteroid transportation. After processing the mined asteroids, the next thing is to transport it for storage or onward transmission to the purchaser. The most lucrative opportunity is platinum group metals, category of the few space commodities that will be shipped back to Earth. These materials enable so many different high-tech processes. This picture shows artist's concept of an astronaut performing a tethering maneuver at an asteroid. Asteroid transportation. After an asteroid's minerals and resources have been exhausted by the mining project, the equipment can then be transported to the next asteroid. This picture shows artistic illustration of asteroid mining operations. You've been watching and listening to Asteroid Mining, a prospective contributor to the global economy, presented by Dr. Ayansola Ogundele. Thank you.